Luis wrote me an email telling me that he wanted to work with me on this thing, and then I was left on my own to figure it out. So I will tell you how that went, and also some reasons, because after a year of doing this, it all seems very normal, right? So logics that have contradictions as logical truths. Well, so I try to put myself in the shoes of someone who actually finds this as a crazy idea. And mainly, what I think that such a person would say is that, first of all, what we call conjunctions and negations are no such things. So that would be a good reason to say that we're not making sense when saying that there can be logics with contradictions as logical truths. Another reason is that even if they granted this, that they are conjunctions and negations after all, then it seems like we're switching or modifying in a suspicious way the meaning of the word contradiction. So finally, that what we call logics aren't actually logics, maybe because they are missing something that only true logics have. Okay, so that's the plan for this talk. And this is part of what the email said. Like when Luis told me that he had this project and that maybe I could be interested, he told me exactly this, that Graham Priest told us that Aristotle discussed views on contradiction other than dialectism, but that even Priest seemed to be treating them as equivalent to trivialism at times. I obviously had no idea what he was talking about, so I went back all the way to Aristotle. And I assume that a good starting point would be to remember that in Book Gamma of the Metaphysics, Aristotle presents us with three versions of the Law of Non-Contradiction. So the first one is ontological, because it tells us how things can and cannot be. The second one is more, I don't know, I have read people call it doxastic and other people call it normative, but the thing is that it tells us what we are able to rationally believe and not believe, and contradictions are the kind of things that we cannot possibly rationally believe. And finally, the semantic version that tells us that simply that opposite assertions, which here is obviously interpreted as a sentence and its negation, cannot be true at the same time. So taking this in mind, I could see in a clear way, let's say, the appeal of what I like to call Priest-style dialectism, because what makes it so appealing, according to me at least, is that it has quite a clear and elegant challenge for each of the formulations of the LNC. So we get that dialectists believe that contradictions are among the things that can be true in the world against the ontological version of the LNC. Also that, given that, because something that is very much discussed is that Aristotle seems to be trying to make the doxastic version hold based on the ontological one. So given that there can't possibly be in the world such things as true contradictions, then if one believes in them, one is being irrational. And well, dialectists disagree, because they say that given that contradictions are among the true things in the world, then they are among the things that we can rationally believe in. And finally, we all know that Priest's preferred logic for dialectism is LP, and so in LP, it so happens that true contradictions are made of true, well, designated opposite assertions, providing a challenge for the semantic version of the LNC. But one needs to remember, when taking this into consideration, that dialectism is different from prior consistency. And I I don't know, there are some people who argue that sometimes these two get confused, and clearly it's important not to. It's important to take, to always remember that paraconsistency is an idea about logic. It's the idea that a logic can accommodate true contradictions. Usually this happens because of rejection of IIF and ECQ. And it is true that dialecticism and paraconsistency go well together. But there are obviously people who think that we can be paraconsistent without necessarily believing that there are true contradictions in the world, and even that it's rational to believe that there are true contradictions. So this gave me a sense of what we were trying to do. That what we were trying to do in the paper was to take advantage of this distinction. So once one recognizes that people who believe, I don't know, in classical ontology, let's say, can believe in paraconsistency, and obviously dialectics too, then people who hold other ontological theses can do the same thing. But what I found really troubling is that I had no idea of how such thesis would look like. Fortunately, the email did reveal what we would be talking about, and basically what we are doing is taking Priest's discussion. So in his discussion of the Law of Non-Contradiction, which is the first chapter of Doubt True to be a Liar, Priest mentions these three characters. He mentions those who follow Heraclitus, which is Aristotle's original opponent in the metaphysics, who is said to believe in contradictions, not because he's ignorant, but for the sake of the argument. He does mention Hegel too, and he mentions trivialists. And then it became clear that what we would try to do is precisely that, show that these clearly non-logical stances on contradiction could actually be formalized. So we started by providing these very brief, maybe unfair reconstructions of the historical views on contradictions. Mainly because they all had faced at different times the same kind of criticism, which is that one can be seriously talking about them when it comes to logic. Like, we all know that Heraclitus and Hegel believed that there were true contradictions, but whatever they were saying about it couldn't possibly be formalized in a system of logic. So our goal is to prove these people wrong. So what we're trying to do is to prove these people wrong by introducing what we call and what we believe is an actual logic for each of the views that I just presented. So I will talk to you about each of the views and their corresponding logics. As we saw, the first one, and Aristotle's original opponent, is what Dancy, I think, calls Antiphasis. And Antiphasis supposedly following Heraclitus, which we have gotten some comments about. Apparently, we took this pact very lightly, and then the people who actually know their Aristotle told us that Heraclitus probably didn't say any of those things. So that's why we're calling him Antiphasis and not Heraclitus. Supposedly, he contests the validity of the LNC, stating that it is possible to believe in true contradictions without being ignorant and without falling into any of the explanations that Aristotle gives. And when one interprets this affirmation kind of weakly, Antiphasis doesn't seem like very different from a dialectist. We're taking this character to say something like the only things that can be true are contradictions. So he would probably believe there are no other logical truths, but he doesn't seem very different from a dialectist. So we have a stronger position, which is that Antiphasis actually believes that contradictions are the only possible logical truths. Everything else is either a logical falsity or just contingently true. So in that vein, we're proposing the system HK as our logic for Heracliteanism, which is a collection of truth values, ordered as you can see, and which we're intuitively reading as truth, atomic falsity, and falsity. We provide the following definition for validity. So A follows from gamma if and only if there's a valuation such that any B that's here gets any value which is not false. And then for all B's in gamma, they must be either less than or equal than the value assigned to A. So I think it's quite straightforward. And then we have the satisfiability conditions for the language. So atomic propositions are all atomically false. This is our proposal for negation, which actually is something I think I'm not worrying about after Hitoshi's talks, because it is actually already treated so you can no, I think that's I think that was wrong. Yeah, because it was supposed to look like this. And clearly that one doesn't say that. Okay, so it's a good thing that our negation looks like this. Not like whatever I wrote there. Sorry.
Why?
Because it says that in any other case, the negation of A is equal to A.
Yeah, I know why those are different. I mean, why is that a good one?
Because it's the one we use in the paper. Like, I have no idea what I was thinking about.
That legitimize everything.
So, see, I wrote that and I have no idea why. So maybe I copied a line from somewhere else, but yeah, that's not supposed to look like that. And then we have our controversial conjunction, which says that the conjunction is true wherever B, the value assigned to B, is the same one as the one assigned to the negation of A, and it's false otherwise.
But that is never going to happen for
it is.
P and not P.
Yeah, because you get B. This one, and then here.
It's not going for not P and P.
Yeah, that's what I meant.
For, sorry?
Not P and P.
Yeah. Oh, you mean this one, like for atomic, conjunctions of atomic propositions are all false, I think. Yeah. Yeah, that's a good point. I hadn't noticed that. Thank you. So I think this holds for formula which are not atomic propositions, I guess.
Okay with this.
Yeah. Well, ideally, it should work like this. So then we get T here, a lot of bottoms, and then we get another. Yeah. So it looks like this.
You can, I'm sorry, you mind if I?
No, I don't mind.
You could probably, if you change the truth condition to if VB equals V not A, or VA equals V not B, that would probably fix that.
Either, so what?
Either VB equals V not A,
Yeah.
or VA equals V not B.
B, A, equals.
If it meets one of those criteria,
Yeah, either one of them. Okay.
that would probably get you.
Okay, thank you. And then we get what we think are uncontroversial disjunctions and conditionals, because they're based on equivalences from classical logic. So, and finally we get, yeah, I know what happened. I translated these slides and left all the typos there. This is an if and only if. Sorry. So that's our definition for the biconditional, which I will not be speaking about today because I'm not sure I have many things to say about it. So okay, that's the system HK, and our second view on true contradictions is the Hegelian one. And so I think we can all agree that Hegel believed in true contradictions in a way that was neither Heraclitean or dialectist. So we decided to very, very roughly summarize what Hegel was saying as the idea that true contradictions exist only in the conceptual level of language as opposed to existing in the real one. And for that reason, our logic for Hegelianism, which I don't know how to say either in Spanish or in English. In my defense, I didn't name it. He did. So. It's made out of two sub-languages. We have the language of the conceptual and the language of the real. In both cases, validity is understood as A follows from gamma if and only if the intima of gamma is either lesser than or equal to A. So both languages share our collection of truth values, which is quite strange, but not too strange, I hope. So we have the truth as the only designated value, and then we have the major contributor to truth and the minor contributor to truth, non-designated values. But they, let's say, are on equal standing in the sense that there is no order among them. Okay, so this makes, for instance, we'll see that it makes the negation of this logic interesting because, and validity too, because there are cases where one can determine which one is the intimum value. So again, we have satisfiability conditions, which again, except for the negation and the conjunction, the conditional, look quite normal, I guess. So what we have here is this junction that is defined by the lower bound, let's say, as is sometimes done in classical logic, and then this is quite close to the generalized definition for the conditional in three-valued logic. And then we do this substitution for the language of the real, given that they need to be different from each other in order for this to be truly interesting. And finally, we have trivialism. So it should also be quite uncontroversial that trivialists believe in the truth of contradictions, but not in the same way that any of the other views I have been talking about do. So it should say here also that they simply believe that everything is true. So the fact that there are true contradictions, or that contradictions can be logical truths, follows. And as in the other two cases, we have our logic, which begins with a collection of truth values. In this case, we have the truth as our only undesignated value. So this logic lacks a collection of non-designated values. And as a consequence of an order, but it's just because of how the collection of values is made. And so in this case, the satisfiability conditions, as you can see, are completely classical. So I get the sense that we're getting ahead of ourselves, because as I told you, after a year of working on this, it all seems pretty normal. So if there are no questions about everything I just said, yes.
I take it as an invitation for questions.
Of course.
So one slide back, I had anticipated that when you were going to give us semantics for trivialism, that you're just going to evaluate everything as false by default, or something like that. But I don't see how this corresponds to trivialism.
Because of our collection.
Are both bottom and top designated?
Yeah, no, the fact is that this is our only value in our collection.
Wow.
So our guess is that we can have the structure of classical logic as is, and then just remove bottom, so that everything is true.
Can you go
So is it partial evaluations or partial functions or something?
Maybe. Can I go, sir?
Yeah, exactly. So if you back, because then what do you assign to not A if you assign top to A?
Well, nothing.
Right, so it's not a function, right? So it's a partial function.
Yeah.
I think Luis has something to say.
Yeah, but now she's presenting. Because I have a very different understanding of trivialism and how it connects with. There are some properties of bottom, let's say universal properties, and some universal properties of the top. And they are all preserved in trivials. But for some reason, when you have only one truth value, you keep all those universal properties of the bottom, but it's just a definitional variant of top.
So bottom is top.
Yeah.
Okay.
Right.
Yeah.
So why is that a partial function? Now I'm confused.
No.
It's
so-
defined
No,
on
it
everything.
is not. It is. If you
okay.
go my way and then you get only top and forget about bottom, even as a definitional variant, then it's a partial function. And then if you do as he says, you recover all the properties of bottom, but with the understanding that top is bottom.
Okay.
Which means he's a crazier trivialist than I am or something.
No,
No, but
only one true and possible true.
But this way is a partial function.
Yeah, so I'm describing it, yeah.
But then not A, for instance, is not true anymore because it doesn't get truth value, it's a truth value. It doesn't get a truth value at all, so it's scarcity.
Yeah, well,
But
because,
everything has to be true, right? Even not A. Or welcome.
Or everything that's meaningful.
Right. So why? Right? So you would have A, it's true. Not A,
it's
it's
also
nothing.
true.
Then not A is true.
Yeah.
So you can't kind of claim that not A is not meaningful. That is not a good way to do.
But I think that maybe what I meant is that because the trivialist accepts that everything is true, then both A and not A would get assigned top from the beginning.
But there it says that not
Yeah,
A
just in case you were to find something. Yeah, just in case you were to get to something, to some A that were. No, I don't understand what I wrote. Just give me a second. No, I'm pretty sure I got it right. It appears like this in the paper, right?
Like this?
Yeah.
Yeah, it does.
Okay, so.
But that's Luis's proposal, not the partial. This is not the, okay, so this is not partial.
Yeah, I guess. But
Ah.
then why don't we have something on bottom as a definitional variant of top? Did I just forget about it?
You just can get it.
Yeah, maybe I just forgot about it. Let's go with that. Okay, so yeah, we're going with that one because apparently I forgot to correct some typos and to add that bottom is a definitional variant in this version. Okay, so I think everything makes sense now.
Mhm.
Okay, good. So we'll forget these misunderstandings happen.
One understanding.
And we will make everything seem like it has been really easy, even if it wasn't. So it got me thinking that it would be an interesting exercise to examine what people who actually think that this is a crazy thing to do would say. So as I told you, the first thing that came to mind was that what we're calling conjunctions and negations are actually no such things. So this is my very weak, I think, defense of why our conjunction is a conjunction. And what I would say is that, well, it actually is one, and that we know that it is because the satisfiability conditions are similar enough to the classical case. So, as we can see here, in all cases, the falsity condition for the conjunction remains the same, while we kind of make a little switch here, which might seem more radical if we follow Thomas's suggestion, but I think that maybe I can explain my way around that. But the idea is that the truth condition asks us for two things to happen together at the same time, right? So if one is, I don't know, sort of a minimalist about what it is for it to be, for connected to be a conjunction, then one could say that this is not such a radical departure as it seems. However, even if that's granted, it turns out that in any case, does the conjunction validate anything useful? They don't simplify and they don't commute, which I think is part of the reason that we maybe need to add that. Because I noticed that in this case, you have to get both conjuncts in exactly this order. Because once they're switched, then B is no longer equal to the negation of A. So the resulting conjunction is false. So my response to that is that maybe conjunctions are not meant to be useful, right? So it is true that conjunctions which validate adjunction, simplification, and commutation and the like are quite useful, and one can argue that they are close to what we do with natural language. But I think that maybe there can be other things that can be regularly called conjunctions, which are kind of weird, like the one we're proposing. Yeah, the case for negation seems easier. As I told you, when I found out that I had messed that slide up, was that our negation is meant to look like this, and that it is actually a negation from another logic, from P1. And according to Hitoshi, at least, it's a contradictory forming operator, so there should be a strong case for it being a negation. And as I told you, the other case is more difficult, but because the truth table for that this and this. So it looks like this. Where if you remember, there is no way to compare these two. And then there's the fact that it does turn our only designated value into a non-designated one, but then it never goes back to designation. So double negation looks like this. So there's kind of an idea of a negation there, in the sense that we're switching these two up, but they're both non-designated, and it lacks an order, so sometimes even I have trouble making sense of this as an actual negation. But yeah, I think, I don't know, I hope that one could argue that maybe negation-like behavior is close enough, or else maybe we can come up with a better explanation, which I don't have right now. But there are some benefits, let's say. And one is that while it is quite evident that double negation fails for both cases, this should hardly count against an operator being a negation. And that even if they're pretty weird, these connectives are not as weird as the conjunction and the conditional, in the sense that one need only stipulate that these two are equivalent to top and this one is equivalent to bottom to recover classical behavior. And something similar happens here. So, yeah, they're really good. They keep some of the spirit of the classical cases, I guess. Yeah, so if that wasn't crazy enough, it looks like someone could say that that is not the important part, because even considering that conjunctions, what we call conjunctions are conjunctions, and what we call negations are actually negations, then we get quite unusual understanding of what a contradiction is, because we seem to have sometimes a very classical understanding of contradictions, where it is, I don't want to say the same thing, but one takes you, in the classical case, having this takes you to that and vice versa. So there doesn't seem to be much to look at there. But I think that it is also usually accepted that when one is not as strictly classical as the people who say that there is no difference in having one or the other, we can agree that this is less likely to happen than this one. So we have many cases of instances of contradictory information appearing as a pair, and then an explanation is given on why we can have that, or why that never turns out to be an actual conjunction. But it seems like true contradictions as an actual conjunction of a sentence and its negation, it's less likely to happen. So, as I said, if one grants that this is not as crazy as it sounds, and we consider this as true logics, then the exact opposite of what I just said happens, because true contradictions are so in the sense that they are always sentences composed of the conjunction of a sentence and its negation, but given that they are not simplifiable, one never gets to the case where we can derive the pair separately. So I find that quite interesting. Also because we have true contradictions, and another thing that we have taken from classical logic is that if one has any instance of a true contradiction, then one has explosion. And in this case, given the features of the logics, we have effectively pair-consistent logics in the sense that neither of these are valid. So, I took false, obviously, for HK, and they're invalid because this is one of the things that I have a hard time making sense of, given that these cannot be compared, that there is not an order among them. Then it seems that when one says things like EFQ is not valid, it's not obvious whether one should take this one or this one to prove it. So it turns out that it doesn't matter which one of them one uses. And well, the logic for trivialism is obviously not pair consistent, but in this case, triviality is not a byproduct of explosion. So after all of this talk about connectives and contradictions, then finally it occurred to me that there may be some other sense in which someone might be against what we are calling logics. So maybe it's because all of the parts they're missing, but they don't seem very serious, at least to me. I mean, this one, as I have been saying, lacks an order of the non-designated values, but I can't possibly think of a reason why someone would say that a language, let's call it, that has nearly everything that classical logic has, for instance, except for an order in its non-designated value, should be taken as not true logic. HK is very well behaved in this respect because there is nothing that it lacks. And even that this is a workshop of contra-classical logic, the first one is quite obvious. The fact that we are doing logics that validate contradictions as logical truths gives us a sense that these logics are contra-classical in the sense that this is something that it's not a classical logical truth. And just for the sake of it, we tried to see what else held. And this was among the things that we tried. We tried to see if they were connected, but neither one is. This one, I think, is quite interesting in that it gives back the exact opposite valuations that classical logic gives for the connective principles. So that's just a trivia. But we do have this as a theorem. This is a theorem from abelian logic, and it is also a logical truth in both cases. In the case of trivialism, which we saw was a little bit different, it lacks proper, let's say, if one takes bottom to be the definitional variant of top, then it lacks proper non-designatedness. But that doesn't seem, at least to me, it also doesn't seem as going too far. And obviously, the logic turns out to be contra-classical in the sense that if everything is true, then there will obviously be non-classical theorems, but it also preserves every classical logical truth along the way. So, summing up, I have been talking about our motivation for the paper, that was to show that one can embrace par consistency along with less common, let's say, ontological thesis. If I was successful, I maybe convinced you that what we call conjunctions and negations are actually such things, and that I will not say that it is impossible, but that it seems very difficult to provide a compelling case to say that what we're trying to do is misguided because what we call logics are actually not logics. So that would be it.
Questions, comments?
Thank you. Very interesting. Elena Ficara and I wrote a paper about, Graham Priest and Elena Ficara and some others. They all think of Hegel as this glut theorist, true contradictions and all this. And Graham, of course, interprets it just as LP. But it's weird because Hegel, not that I'm a scholar, Ellen is, I'm not, but from what I understand, Hegel talks very much along the lines that you just gestured at here, which is A alone can't give you the full truth. Not A alone can't give you the full truth, but it's the conjunction of A and not A, the synthesis that gives you the truth. And not having read a word of Hegel, I thought, okay, well, the way to understand this, right, is to allow, don't let logical conjunction be standard. Let it simplify, let a junction happen, let that. But for the Hegelian thesis, you have this other conjunction, Hegelian conjunction. And it's going to be sort of like what you're doing, where you have these two gappy sentences, A and not A are both gaps, but the conjunction of them is true. Obviously, that's going to fail simplification. I can't remember whether it commuted or not, but anyway, I bring this up for two reasons. One, it is motivated very much in the same way that you motivate part of your idea, which is that A alone isn't enough, and not A alone isn't enough. Not even enough to be individually true. You need them to come together to make it truth. But I don't think you should worry at all about saying that this is not logical conjunction. You should just agree. It's not logical conjunction, fine. It's this other theoretical conjunction that comes into play for certain theories or something like that.
Yeah. I guess my worry was that someone might say that it's not a conjunction at all. Like, what would I say to someone who told me that he wouldn't go along with it?
I get the worry, and I think it is a worry, but again, the importance of the background motivation, you say to them, look, we have certain truths that are not that aren't expressible except when you conjoin them. You say A and not A. And then, so you say it's conjunction like. It's not logical conjunction.
But it's conjunction like, yeah, I agree.
Yeah, good.
Thank you.
Say.
Yeah, so I think this is just, I want to find out what the logics HK and Hegel are.
Just the F there in the name is for Ellen.
Oh, for Ellen.
Well,
Maybe Ellen
Even
published
I
the
didn't
paper,
know
I don't
that.
know.
I told you. No, you didn't.
Is it this paper? What? I didn't think it was published.
Oh, it doesn't
So-
matter. Okay, anyway, yeah.
So here's where let's say I'm clear on this, right? I know what the values are.
Yeah.
And then you assign atoms to these values. In the case of HK, all the atoms go to the same value. In the case of Hegel, they can spread out. And now we have these matrices that allow us to calculate up the values of complex sentences. Okay, so let's say I'm on board for all of that.
Okay.
And now I want to know when something follows from something else. Right, when is an argument valid? Because this is an additional question that you ask on top of these sorts of things. And there are two ways you might answer this, and I thought that you answered it both ways, and so this is where I'm confused.
Okay.
Right, so you could tell me what designated values are, and then I can think, okay, well, validity is preservation of designated value. Or you could say, no, look, there's this ordering on the values, and validity is interaction in a certain way with the order. But I thought you said both of those things, and they would seem to give different answers. So I'm just, so given, say the valuation stuff all works out is fine, just what does it take for an argument to be valid? And like the order and the designation, I think either on its own would be enough. And I worry that there will be cases where they will clash with each other.
Yeah, I think, let me go back. That, I'm not sure, but I think that here, it might be enough.
Oh, so I have a separate worry about this one, which is just that the infimum won't be defined if we have either a C, if we have both a C and a C star on the premises.
But then it would not be the case that this holds.
Ah, okay, so this
if
is,
you-
yep, so
just
that's
in
just
case-
one more condition
yeah.
to meet. Okay, cool. So, okay, so then what
And on the
would
other
this
one, yeah, I
notion
think,
of designation do for you then?
I'm not sure. Because I see the word now, especially here, where
Yeah, so it looks
have-
like, okay, so this is a perfectly good definition, the other one's a perfectly good definition, but then why even bother identifying some values as designated? Why not just?
Yes, because maybe it was that we were trying to capture as much structure as possible. So we were not thinking it through, like maybe one of them is not. Maybe we were thinking that we could provide a definition of what it takes for an argument to be valid, and then have this thing like, well, and we have designation and non-designation and ordering, and that they would clash. Yeah, maybe we were thinking about that.
This is more sort of quick comment, but you mentioned cases in which comma and the connectives come apart.
Yeah.
And I just wanted to mention that one really sort of notable case in which that happens is with like Bogfar and Halden's nonsense logics.
Okay.
That A comma B implies A, but A and B does not imply A.
Okay.
So if you're looking for a way to try and make that work or incorporate a distinction into your semantics, you might want to look at that stuff because it might provide you some avenues to do so.
Yeah, that sounds really great. I was thinking from a much more practical point of view, like our usual views in contradiction, like how much philosophical work has been done on how it is rational to believe in contradictions, and that the presence of contradicting information is not necessarily explosive. And there seems to be an agreement that one can get the pair, and then because any kind of explanation, one keeps it from being a conjunction. But that sounds really interesting. Thank you.
Maria?
Yeah, so actually my point was similar to Dave's, but I would formulate it as follows. I think it's the same thing, but I have some kind of suggestion.
Yeah.
So you could have that only contradictions are true. You can have that only contradictions are
Logical
truths, because only contradictions are true and are so in every interpretation, or because you redefine. So you can either redefine an interpretation, you can redefine the notion of logical consequence, right? Or logical truth in this case, and you can say that, for instance, phi is a logical truth if only if it gets value 0 in every classical value. Right?
Right.
And you were saying that these two strategies were overlapping, right? If it's no.
I think it's a different.
I think I was doing something else,
Alright, yeah.
but don't worry about me, go ahead.
In this case, isn't it much simpler just to go for the second one, to redefine logical truth? Because, or do you want to capture something else?
I think what we want is to capture something else. So you would say like something on the classical understanding, because I think it was obvious, but probably not, that the conjunction is made that way, so that the only assignments that get truth is when one of the contents is the negation of the other, and that in the special case of this schema gives you that.
Yeah, so
And what you're saying is that, if I understand correctly, that it would have been easier just to say, leave everything as is, and then just say, well, when given that in classical logic the opposite happens, then that will be our notion of logical truth.
yeah, because I was thinking about, so maybe I was generalizing too much the notion of contradiction. I thought a contradiction, or at least, I mean, classical logic. I thought, a contradiction is something that is always false, by definition, right? And so when you said we want the contradictions to come out as logical truths, the only logical truths, then I was not just thinking about formally of the form A and not A.
Okay, yeah.
I was just thinking, the only way I can think of that characterizing these formally is just that they get value 0 or value bot or whatever in every valuation. But okay, so you just want those.
Okay, yeah, because of course in classical logic we could get this. If we got this, then it means that these separately are true, right? And so, that's what, no, that this can happen, that this both can be true, and then that's why in classical logic we have that contradictions as a conjunction are always false. And maybe that's why I found it interesting to talk about this understanding that we have and how maybe if we had only changed the definition of a logical truth, it wouldn't have been such a departure from that understanding. And that's why I find it especially appealing, because I'm not sure, but I think that if we do that, it would be like inverting classical logic.
Yes. I thought that's what you wanted, because I understood that contradiction was classical contradiction.
That truly is one way to doing that, but then we would get just think about everything you know about classical logic and turn it on its head, and then you wouldn't have maybe this discussion wouldn't be as well motivated. So because it's precisely, I think, what you're telling me now. Like when I think about a truth, when I think about a contradiction, I think of something that is false by definition, which is something that our classical understanding is this is part of our classical understanding, right? That even if you are someone that believes that this happens at times, then this cannot happen, simply cannot happen. And I don't know if we would get. This basically says that even if we concede that sometimes this happens, this is always false. And we get the classical understanding, because everything works as expected, so we get this when evaluating this schema. And I don't know if going that way of just inverting everything would have gotten us to the result here, which is that conjunctions, like sentences with the structure of a conjunction, are always true, while the conjuncts are not necessarily true. Neither one of them.
Okay. Thanks.
Excellent. I think that my question is a little bit related, because it has to go back to your motivation or the motivations for Antiphasis, which is why do you want, first, why only contradictions like A and not A? What's so special about those among all the other things that we consider logically false that want to be included as logically true? And second, why all contradictions and not just some contradictions are logically true? I think it also has something to do with Bell that said, like, there's something in certain formulas that need the conjunction with the negation to be true. So just those questions would maybe help you understand what the project is at the philosophical level.
Okay. So the first part was what makes these schemas so
Special.
I think that I'm going to go with the cheat here, and I will say that we need it in order for the logical to be contra-classical.
Can you say a little bit more?
Because we were not sure of what else we would get. So we know that we have the theorem from abelian logic, but then when you're thinking that, at least, I mean, I think this is how I see it, that we have these historical motivations, and at the same time, it would be kind of fun to explore what would happen if contradictions understood in a rather traditional way were logical truths. So we could get, on a broad definition, we could get contra-classical logic. And that's my explanation for that bit.
Okay, and then-
It feels like cheating, but because it's accepting, like, it was for the sake of contra-classicality.
Sure.
And the other bit is because it hadn't occurred to us to have a normal behaving conjunction, let's say. Because definitely that would allow us to say, well, there are formulas that if we have like Hegelian conjunction and then logical conjunction.
But even with just one conjunction, you can get if you have like the three-value logic, you can get that some of the formulas that are assigned one of the values when they're conjunct with their negation, you get true, and others not. They're classical, and then you're going to get some contradictions that are going to be logically true and others.
I think,
you need to have it too.
yeah, because I think it does happen. Because I talked about this not being commutative. So that if you have a certain order of values, but I guess that we didn't see that coming. So we were sure that every pair and its negation, every conjunction made of a sentence and its negation would turn out to be true. So yeah, maybe we just weren't careful enough.
So I have a kind of methodological question.
Okay.
Because it seems like a really sort of cheap way to do like the HK would be just to say, define a map of your language, everything is of the syntactic form, phi and not phi, map that to true, everything else the false. And you're not doing that because you, I guess, want to keep things sort of compositional, that the truth of a whole is defined by truth of its parts.
Yeah.
But in some of these cases, it's not clear what compositionality is actually hitting for you. So I guess I was sort of curious about what the benefits of having a compositional semantics would be for cases as sort of, unique as these. Why hold on to compositionality?
I don't think there's an explanation behind that. It's just how we built the logic. So yeah.
So I have a question on the philosophical part. And it has to do with some of the motivations for the logic. So I'm thinking that one reason you might want to have something like compositionality is because you are trying to give something in the spirit, that's something which is actually a logic or resembles a logic which respects the philosophical spirit of something like the Heraclitean or the Hegelian doctrine, right? And you have to distinguish that from the from something which is a metaphysical theory, which has some logic built into it, which is which, for example, from Bill's discussion, I think, and from his discussion, I think that if you did those things, you will end up with basically just something like a metaphysics with some logic built into it, right?
Yeah.
So here's a case, I don't know, maybe you can tell me what you think about it. So for example, the Neo-Hegelians, they had this interpretation of Hegel, which might be false, but which I think is interesting. So they thought that every proposition about the world was only a partial truth, and you could only get the whole truth, not with just contradiction, but if you took the maximal proposition, so to speak, and then that's the only proposition that will have a truth value, the true truth value, and every other proposition will have something like a degree of truth. So you will have something like, if you follow the spirit of that logic, you will have something like a multi-valued logic, and you will have to assign different truth values to different propositions in as much as they go closer to the maximum proposition, so to speak. So I guess my question just comes down to how much, in what respect are you trying to offer a logical reconstruction of these views, or a metaphysic for these views? Because if you want to offer a metaphysics, then you don't need compositionality or something like that. But if you want to do something like logic, then maybe you need those principles.
Yeah, I think I agree with that. It's because we're focusing more on making logical sense of these metaphysical views on contradiction. So I guess we were trying to be as explicit as possible, and maybe compositionality seemed like the way to go.
So you're sorry. So just very quick. So you're taking these statements that in Heraclitus' works and Hegel's works as sort of principles of reasoning of pure logic, and this is how you would codify them, I guess. I don't know. Is that the
like taking, for instance, the way I make sense of dialectism. If you see all of these views as composed of an ontological component, a doxastic component, and a semantical component, then it seems like we already have the first two, because they actually believe in true contradiction, like things in the world. So we were trying to provide the missing parts, and yeah, it seemed like I don't know if I should say easiest, most straightforward way to do it. And I was going to say that about the neo-Hegelians and stuff. I think the notion of all truths being partial is kind of baked in the interpretation of the truth value, because in this case, we're not taking non-designation to be equivalent to falsity in any sense. Maybe I didn't write it here on the slides, but the paper clearly says that we know that Hegelians don't think there is such thing as falsity, and by the satisfiability conditions of most of the connectives, you can see that the interesting bits, so to speak, happen with the other truth, the contributors to truth, and not truth itself.
Thank you.
Let me say something about the connection between model theory and what we could call philosophical interpretation of the values in the model theory. At least for me, there is no direct connection between both levels. So we could work in model theory, and this work is not directly connected with only one philosophical interpretation. So we could adopt this matrix and get different philosophical interpretation of these values, and are completely compatible with this logic. Do you believe that when you use this matrix or the logical consequence relation, there is only one philosophical interpretation, so the connection between this matrix and the Hegelian stuff or is directly connected, or?
I know. Yeah, I agree that this is just a structure, so to speak, and then one can, yeah, in that sense, I think.
Because maybe that is only information. It's not a real stuff.
Yeah, I think that that's what we were trying to do. So obviously we need to choose only one structure and only one interpretation. And in this case, the interpretation that we would give was set by the discussion that we adopted, which was pre-discussion on true contradictions. But yeah, I don't think that there is a strong, unique connection between this and the philosophical interpretation we're offering.
Maybe in order to talk in the language about true contradiction, you could add a true predicate in this stuff. Try to get something about that.
Okay, that sounds, yeah, I think we could try that. We haven't thought of that, but yeah, thank you.
Any questions?